do a few practice problems that have to do with osmosis. And the first one we're going to do is this one talking about number 1. So the first thing I like to do is draw my scenario. So I'm going to change the color to black, and I'm going to draw a little beaker, and then I'm going to draw my cell. And then I like to give the information that they've given me. So they said inside the cell is 20% water. And outside of the cell, that means in the beaker, it's 80% water. Now, you can imagine that for the purposes of this assignment, anything that's not given is the opposite. So for example, in this case, we know that 20% is water, so 80% is something else. And here, we know 80% is water in the beaker, so we know 20% is something else. However, the question asks, where does the water go? So that's our concern. And water, as you know, via osmosis is going to travel from where there's a high concentration or amount to a low concentration. So in this case, the water is going to go into the cell, and I will write that on my worksheet. Okay. Next up, I'm going to show you how to do number 3. Because number 3 takes it up a little bit. So we'll draw our beaker once again, and I'll draw my cell. Now, in this case, it says inside the cell we have 25% sugar. If you remember, everything in the cell is going to add up to 100%, and you can assume anything extra is water. So if 25% is sugar, that means 75% is water. Outside of the cell, it gives me that 75% is sugar, and so that tells me that the rest of it, the other 25%, is water. Now, the question gave it to us in terms of the sugar, but the question itself asks, where does the water go? So let's look at the water. Remember, water moves from an area of high concentration to an area of low concentration. You can see there's more water here, so the water is going to travel out of the cell and leave the cell. So in this case, I would write out of the cell. And that's how you do these type of problems. Go ahead and try the next 2. The next section is about dynamic equilibrium. So dynamic equilibrium is basically the state where the rate of molecules moving in and out of the cell is equal. So essentially, your molecules are going to move from areas of high to low concentration until the rate is equal. Eventually, the particles will mix to such a point that you have a uniform mixture, and the concentration of the particles is the same in all areas. Concentration, temperature, and pressure affect the rate of diffusion in this way and help even this out. So if we have a high concentration, like a lot of particles, a high amount, diffusion is going to happen quickly because more particles are going to be moving across the membrane. If you have high temperature and high pressure, when you raise the temperature, molecules shake a lot, and when you raise the pressure, same thing, and the molecules are going to crash into each other, and they're going to diffuse more readily as well. So now we're going to take a look at our solutions and talk about a little bit more about osmosis. So if the solute is the green dots, which solution has more solute than inside of the cell? So here's the solution, here's the cell. Which one has more solute or more green dots? Yes, it's the hypertonic solution. So a hypertonic solution occurs when the solvent water concentration inside the cell is higher than outside of the cell. That means that there's a lot of solute outside of the cell. So maybe you're in a very salty solution or a very sugary solution. Then there's more water inside the cell, and so water moving from high to low concentration is going to leave the cell, and the cell is going to shrink. I like to remember this because a lot of times the hypertonic solution is sugary or salty, and sugar makes you hyper. So I just remember sugar, hyper, hypertonic. The cell shrinks. The alternative is a hypotonic solution. This is when the water concentration inside the cell is lower than the solvent concentration outside of the cell, meaning there's more of some other substance inside the cell than water compared to outside of the cell. And so this might be if you put your cell in pure water. Water is then going to diffuse into the cell, and the cell could expand and potentially even burst. The ultimate goal is an isotonic solution, and this is where our solvent and solute concentration is equal on either sides of the cell so that water can diffuse in and out at equal rates. And in an isotonic solution, a cell stays the same size. So here's some more practice problems. Let's try number 1. We want to know which direction the water will travel and also whether the cell will grow, shrink, or stay the same. So once again, I am going to start with what I know, which is my beaker and my cell. And I know that inside the cell, I have 20% water. Let's try this one more time. Inside the cell, I have 20% water, and outside the cell, I have 80% water. So, where is the water going to travel? It's going to go into the cell because there's more water outside than inside of the cell. And when water travels inside the cell, it's going to grow. The cell is going to grow. So I'll write grow here for you. Go ahead and try number 2. And we'll leave off there for today, but